Homework 15, Properties of Logarithms, Video 3, Expanding a Logarithmic Expression, Part 2. At the end of the previous video, which went a little bit longer than I wanted to, but it happens, I mentioned that there's a way to expand a logarithmic expression in one move instead of having to pause and ask yourself which rule, which rule, which rule. This only applies when you have a logarithm of a fraction and or multiplication problems. Now, this one does involve addition and subtraction problems, but at its core, this is a fraction with a multiplication problem on both sides. The quantity x plus 1 times the quantity square root of z minus 1 on the top, e to the 5th times the quantity w plus 2 to the 7th power on the bottom. So as long as everything is part of a multiplication problem or part of a subtraction problem, you're good to go. By contrast, and I hate going off on a tangent before you even started the problem, if you had a log of an addition problem like the log of x plus 5, natural log of x plus 5, or log of w squared minus 3, you couldn't do a single thing with either one of those. This is neither a this is neither a product, quotient, or power. This is neither a product, quotient, nor power. This is a sum, this is a difference. There are no log rules about what to do with the log of an addition problem or the log of a subtraction problem. There are only log rules for the log of a product, the log of a quotient, and the log of a power. Now those factors may be addition and subtraction problems, which is okay. So how do you expand in one move? Well, really what it boils down to is how many logs, what numbers are in front of them, and who's positive or negative. The rule for how many logs is simple. How many factors do you have on both sides? Remember, a factor is part of a multiplication problem. On the top, we have two factors, x plus 1 and the square root of z minus 1. On the bottom, we have two factors, e to the 5th power, w plus 2 to the 7th power. Every factor gets its own log. I will need 4 logarithms. Any factor with a power, the power will wind up in front. This x plus 1 does not have a power on it, so there will be no coefficient. The z minus 1 does have a power on it if you are to the point where you instantly recognize that the square root of something is the same thing as that something to the 1/2 power. That needs to become an automatic move. So the square root of z minus 1 is the same as z minus 1 to a 1/2 power. So where does the power go? In front. So the z minus 1's natural log picks up a coefficient of 1/2. On the bottom, we have e to the 5th. The e has a power, so the power goes in front of the e's log. And we also have w plus 2 to the 7th. The w plus 2 has a power of 7. So the 7 goes in front of the w plus 2's natural logarithm. The only other thing you have to negotiate is which of these logs are positive and which are negative, and the answer is really simple. If the log's argument was originally in the numerator, that log is positive. If the log's argument was originally in the denominator, that log is negative. So the w plus 2 was in the denominator, its log is negative. The e to the 5th was in the denominator, its log is negative. The square root of z minus 1 was in the numerator, its log is positive. And the x plus 1 was in the numerator, so its log is positive. And so instantly we can expand this into the natural log of x plus 1 plus 1/2 natural log of z minus 1 minus 5 natural log of e minus 7 natural log of w plus 2. Now, all that said, this would still be counted wrong as a homework question because there is one log that we're not done evaluating, and it's this one. Remember that natural log means log base e. So this log is asking a question, what power do you put on e to turn it into e? And the answer is 1. In fact, anytime you see the natural log of e, you are not only expected to recognize it, but you are obligated to go, wait, that's equal to 1. Always and forever. So anytime you see natural log of e, you're expected to turn it into 1 and then continue. So this becomes negative 5 times 1, which is just negative 5. So natural log of x plus 1 plus 1/2 natural log of z minus 1 minus 5 natural log of e. Oh, whoa, whoa, whoa. I just got finished saying that the natural log of e is 1. So minus 5 times 1 is just minus 5. And then minus 7 natural log of w plus 2. I don't think I put any in your homework that are this congested. But I wanted to make a point that if you know what to look for, you can do these expanding problems in one move. Every factor on top becomes part of a positive logarithm. Every factor on bottom becomes part of a negative logarithm. Any factor that had a power, the power counts down in front of it. If you happen to see a radical, get ready to turn it into a fraction power and be on the lookout for logarithms that you can answer.